The way in which we make our materials is in a lab setting, and we isolate everything and put the fungi, but it's different than what happens in nature. In nature, fungi collaborates with other organisms and thrives. What I like about mycelium-based composites is the fact that there's just so many things that can be explored, so many unknowns, and the way that one parameter that you change in the making of the material affects its performance. So I like to explore these and learn from it, make our own materials together with the living organism, the fungi, and then use that material in a design application. So they go hand in hand in this process. That's what's fascinating for me. Last spring, we were invited to contribute to a biomaterial building exposition at UVA created by Katie McDonald and Kyle Schumann. We fabricated the components, and then the assembly of the components took place at UVA grounds in mid-March 2022.
There were 5 different teams from 5 different schools nationwide working with different biomaterials, and we saw let's say the enthusiasm among the scholars and among the people who want to start working with these sustainable materials and change their method of using the materials and method of shaping the materials to make a sustainable future for everyone.
Another project that the Format team is working on, a collaborative project, is the Mycelium project. It's a collaboration between Format Lab and Soft Lab at PSU, which is directed by Dr. Felicia Davis. And the project involves 2 PhD students, Ali Gazvinyan and Farzana Okazyan. They came to me and Felicia with this idea of, can we explore this? Can we create such a collaboration? So I think the idea should be credited to those 2 PhD students. The idea is to use knitted textiles as formwork to shape the composites, but also as a reinforcement to provide some tensile capabilities to the composite, mycelium-based composite. We saw that there are very few applications for acoustic panels using mycelium-based composites in architecture. So with Natalie Walter, my master's student, we wanted to explore making our own composites and testing them for acoustic performance, acoustic absorption performance.
Acoustics is kind of an interesting paradox because on one hand, we want more acoustic materials in our buildings, but the conventional acoustic materials that we are using now are not socially or environmentally sustainable.
We cultivated different types of composites. All of them are tested for acoustic absorption. We made statistical analysis and developed some simulation protocols to test room acoustics of panels that are made with mycelium-based composites.
So we hope that this will be more integrated in the design process, as being super conscious about the material use and kind of the practices that go along with it.
3D printing, that's also a project that we work on called Microprint, together with my master's student Alale Mohseni. So 3D printing actually is something I was thinking about when I started to work with mycelium in my hacking materials and production methods class immediately.
Mostly people now are using molds and formworks. So I'm using a 3D printing method as a waste-free fabrication method to form this material. In my case, I'm using waste cardboard as a primary substrate to cultivate the mycelium ion. First, we prepare this material in bags and then let it grow for a while. And then we need to move the material from bag to the formwork. I need to process that, mix that, and then 3D print that.
And recently, together with other students in my lab, they actually worked together in adapting an extruder end-of-arm tool for a 6-axis robotic arm, which provides even more freedom of movement in 3D printing these components. There's still a lot that can be explored in relation with 3D printing. I'm very excited to keep that research line going on.
Working on research topics such as what Benay Gürsoy and her team are working on positions Penn State to lead the conversation nationally and internationally in the area of construction material and architecture.
Penn State is the perfect institution to pursue this kind of research. We have a long history of expertise and strength in the study of fungi. We have a huge research infrastructure built around growing and understanding fungi and their relationships with pathogens and commensal organisms.
So it places Penn State in an awesome position to guide these impactful and long-lasting contributions.